So a new Python data type, lists. Lists are used to store multiple different items in a single variable. They're represented by square brackets, and each element is separated from each other using a comma. So this is a list that contains 3 elements, a string, an integer, and a floating point number. And that's just to point out that the elements inside a list don't necessarily have to have the same type. Items inside a list are indexed, so they have an order, and the first item corresponds to index 0. So Python is 0 indexed, and if I index this variable with square brackets, then I can get the very first item using a 0. You can also use negative indices, where index -1 corresponds to the last element. And if you try and index something out of range, then you're going to get an error thrown. Lists allow slicing, which is operation of getting a range of items. You can do that using this syntax. I'll just point out one thing here, which is that one case where new lines and indentation are not treated as they usually are is between square brackets, or between parentheses actually. So this is often because it makes it easier to read. So here I'm using slicing to get the first 3 elements. It's inclusive of the first index, but exclusive of the last. So it's going to include the element at position 0, but not include that at position 3. And let's just be really clear here about the syntax, which is square brackets, 2 indices separated by a colon. You might expect Python to throw an error if the slice indices are out of range, but because we're slicing, not indexing, Python will just go as far as it can in the positive or negative direction. If you don't specify an upper or lower bound, it's going to assume that the lower bound is going to be 0 and the upper bound is going to be the very end. That is -1 would be the index, which is always true. So here you can see that this index is all the way up to the end because I haven't provided a second index, a stopping index on the other side of the colon. And here's the other case where I haven't provided a starting index. You can also add a third number to the range separated by another colon, and this third number corresponds to the step size of the range. So here you can see me using that. There's 2 key characteristics of lists which you should be aware of. One is that they are mutable, and the other is that they are ordered. So mutable means that you can change the items in the list. You can replace, okay, let me just do that in the right order as it says. Lists have 2 key characteristics which you should be aware of. One is that they are mutable, and 2 is that they are ordered. The fact that they're ordered means that the items have a defined order, and that order is not going to change. So if you add an item to a list, the rest of the items won't change their order either. Mutable means that the items can change, which means that you can add, remove, or replace any items in a list. For example, you can write something like this, and you're going to replace this element without any issue. So we've mutated that list. It's mutable. We know how to define a list and access certain data inside it, but what else can we do with it? So let's look at some of the most common methods of a list. One of the most common things you'll do is get the number of items in a list, and you can do that using the len function. So this len is a built-in function to Python, and it just resolves to a value which is an integer number of how long the list is. Always going to be an integer. So, and remember, methods are functions that can be called on some Python variable. Lists have a lot of practical methods, and you'll mostly learn about them as you need them, but for now, I'll just show you some of the most common and useful. So you can add data to your list using append. For example, you can add a new string to this list by appending it. But another way to add elements to a list is using the extend method. What's the difference between them? Easy mistake to make. The difference between append and extend is that append will add the new item as a single element, whereas extend will add the element item-wise. So both methods return something similar, but as you can see here, append adds the elements as a whole, and extend actually extends it by this list. So extend isn't going to work on every data type. And mixing these two up is a really common mistake. So you know how to add items, and we can also remove them too. But let's say I didn't know how to do that, so we can look it up as an example, because I want to show you exactly how you should be able to find this stuff out for yourself. So, okay, let's search that up. Right, and this looks like the right link. It's a good resource. So you can see you can remove specific items using the remove method. And another way to remove an element is using the pop method, which is going to remove the element in a specific index given to that method. Or if you don't specify the index, it's going to remove the last item. And the delete keyword from Python can also achieve the same result if we know the index of the element we want to remove. And finally, the clear method simply empties the list in case you want to start over. So another thing we can do is sort lists. And again, there's loads you can do with lists. I'm just going to show some of the basic stuff. But if you want to sort a list, you can use the sort method. So just do a dot sort. You can also sort in reverse, doing the dot reverse method. You can also reverse the current order of list using the reverse method. And notice that these two perform what we call an in-place operation. And this is really important to note. If an operation is in place, it overwrites the existing value of that variable. Other methods aren't in place, and what they do instead is return the value. Maybe it's return the sorted value or the reversed value, but they don't actually change the current value of that variable. So if you have an in-place method, you don't need to reassign it equal to that variable. If you have a method which isn't in place, then it's going to need to be assigned to something if you want to use what it resolves to. So the built-in function sorted does the same thing as dot sort on a list, but instead of changing the list in place, it returns you the variable. So you can see dot sort is an in-place operation, and sorted is not in place, and actually returns the value of that sorted list, which we need to assign to something if we want to use it. So the second data type that I want to talk about here is sets. Sets are quite like lists, but rather different in some ways. So sets are used to store a series of elements, but they only store unique values, so they won't have repeated values within. You can define a set using curly brackets, or you can define it using the set constructor, like this kind of built-in function, which is going to produce a set as a result. So if you convert a list with repeated values into a set, it will remove all the repeated values. We saw that lists are ordered so you can index them to get a specific item. But if we try and do that for a set, you can see that they're unordered. They don't have a specific order, and therefore they can't be indexed. You can apply some mathematical set operations on sets as well. So, like mathematical sets, sets in Python can be used to do things like check the difference between the two sets, or check the intersection of two sets, or check everything that's in both of them, which is called a union. So let's just have a look at running through some of these methods of sets. So union method returns a set with all the items from both sets. Notice that it's called on one set and another set is expected to be passed in as its parameter. And notice that the repeated elements don't appear twice because the result of this operation is a set. The intersection method returns a set that only contains the items that are present in both sets, and the difference method returns a set that contains the items that only exist in the first and not second. The final one I'll show is symmetric difference. This is a set that contains all items from both sets except those which are present in both. And to finish off, let's just see how to add and remove elements in a set as well. You can add elements using the add method, and that's an in-place operation. It's going to change the original content of the set. And if you add an already existing element, this is not going to affect the set, that's fine. And you can remove elements using the remove or discard methods. They both remove a certain element from the set. But what's the difference in that case? Well, let's take a look. Here you can see a very reputable web page, Stack Overflow. This question's got a lot of upvotes, and we can see down here the answer. And the way you should use this is quickly scan the question. Is it roughly talking about what you're looking for? If so, scroll down and look at the first answer quickly. And usually you'll get to what you're looking for pretty quickly. So as you can see here, the difference between them is that remove throws an error if the element's not present. Let's try that out. And yeah, if we run this, yeah, you get the error that's saying that this value isn't in the set. But when you use discard, it doesn't throw an error. So the key takeaways there are basically there's these two data types in Python, lists and sets, and we basically just seen some examples of how you can use them. So have a practice of that on your own and make sure you're comfortable with them.